This lesson we're going to talk about composition functions. So what is composition function? Well, we should know how to add two functions. We can subtract two functions. This is notation of multiplying two functions. This is dividing two functions. When it comes to composition functions, the sign is open circle, little circle with open, little different than multiplication. Multiplication is dots. Composition is open circle between two functions. It means that you're going to replace the second function into the first functions. In order to find the domain of composition functions, you're not only looking for the restriction of the composition functions, but you're also looking for the restriction from the inner functions. Example 1 is asking you to find the composition function when your x is number. This one is a little easier. Why? Because you end up finding exact value. So this first one is asking you to find g of x function with x equals to 1, and whatever that value is, replace it into f of x functions. So g of x function is that, and when we replace x with 1, we end up getting 4 times 1, which is going to be 4. That solution 4, we're going to replace it into f of x function, so you end up getting 2 times x squared minus 3 is what we need to do. That gives you exponent first, so it will be 16, and times 2 will give you 32, minus 3 gives you 29. So let's try one more, right? What about if we have g composition of f of 1? So this time we wanted to find f of one function first, and then whatever that value is, we're going to replace it into g of x. So when you replace 1 to f of x functions, you get 2 times 1 squared minus 3. That gives you 1 squared is 1, times 2 is 2, 2 minus 3 is negative 1. And when you replace negative 1 to g of x, it will be 4 times negative 1. So that gives you negative 4. So if we try one more, but this time we are using the same function instead of two different functions, right? It's still same thing. So first, you're going to replace negative 2 into the f of x function and see what you get. So then it will be 2 times negative 2 squared minus 3. Whatever the answer is, you're going to replace back into f of x function again. So this is negative 2 squared is 4 times 2, 8 minus 3 is 5. Gives you 2 times 5 squared minus 3, which is 5 squared is 25 times 250 minus 3 is 47. That's what you do, right? Okay, so you have one more problem, maybe you can try, right? Or if you're looking at my notes, you will have an answer after you try that number. Let's looking at the next one. What about this time we don't have x variable, right? I mean, number. Even though we don't have number, we are asked to do same thing, right? So then we're going to replace, what's the g of x? G of x is 2x plus 3 in this problem. So that's what we are going to replace it into f of x functions. So then whatever the place that you see on f of x, x, you're going to replace 2x plus 3. So then you get 2x plus 3 squared plus 3 times 2x plus 3 minus 1. This gives you 2x plus 3 squared. You're going to get 4x squared plus 12x plus 9. When you distribute 3, you get plus 6x plus 9 minus 1. Combine the like term. You only have 1 square. This 2 like term will give you 18. This 2 like term, 18 minus 1 will give you plus 17. So that's going to be f composition of g of x function is. Without the number, that's how you're going to find the composition functions. Let's try again with the same function. We're going to go backward. So we're going to replace f of x function into g of x function this time. So f of x function is x squared plus 3x minus 1 into g of x. So wherever you see on g of x, you replace x squared plus 3x minus 1, right? Plus 3. Open the parenthesis by distributing 2. Combine the like term. You get 2x squared plus 6x plus 1. As you can see, even though we use the same functions backward, you will end up getting a different answer, right? So don't forget that. Let's try the next one. Next one, we have not only need to look for composition functions, but this time we wanted to look for domain. So let's try. We're going to replace g of x, which is 4 over x minus 1 into f of x. So f of x is 1 over x plus 2, right? But instead of x, you're going to replace 4 over x minus 1. You have complex fractions. Fraction inside fraction. So in order to get rid of that, you need to multiply by x minus 1 over 1, right? So numerator will cancel out denominator. It means you're going to multiply x minus 1 on the numerator and denominator to all the terms, right? Times x minus 1. And when we distribute, we will end up getting x minus 1 on the numerator. Denominator, we have only 4 remain from the first term. You distribute positive 2 to x minus 1, so you get plus 2x minus 2. And combine the like term on denominator will be 2x plus 2. So this is the function. If you wanted to go a little further in a factor form, you can even say 2 times x plus 1, right? So this is going to be functions. Now, how do we find the domain? Domain, we need to know the restriction. So looking at the composition function restriction, x cannot be -1. So that's going to be the restriction of domain. But by the definition, if it's a composition functions, also inner functions restriction is also a restriction of composition function domain. Here, x minus 1, x cannot be +1. So there is 2 restrictions. So your domain, it will be all real number, but -1 and +1. So one restriction from the composition function, the other restriction comes from your inner function restrictions. And the way that you're going to write this in an interval notation is going to be negative infinity to negative 1, negative 1 to 1, 1 to positive infinities. So that will be domain, and that will be composition function. I'm going to try another one with using the same thing. So in a g of x function, I'm going to replace f of x functions. G of x function is 4 over x minus 1. Instead of x, you put f of x. Again, you're going to multiply x plus 2 everywhere to get rid of denominator. And when you distribute, you get 4x plus 8 on the numerator. Yeah, distribution will be okay. Denominator, you will get 1 minus 1. Minus 1 you're distributing into x, but also same time positive 2. So negative 1 times 2 will give you negative 2, right? So it will be 1 minus x minus 2. Combine, you will get negative x minus 1. So again, let's find, well, that is your composition functions, but if I wanted to find the restriction of denominator, you get negative x minus 1 cannot be equals to 0. So x cannot be equals to negative 1 from your composition function. Your inner function restriction is x cannot be negative 2. So your domain of your composition function is going to be all real number, but negative 2, negative 1. So all the way to negative 2, negative 2 to negative 1, negative 1 to positive infinity. So that's the domain. Let's try one more. Right? One more. Same thing. So we're going to look for not only the composition function, but domain, right? Composition functions and domain. We're going to replace g of x into f of x function. So that gives you 3 times x minus 4, right? And since we do multiplication before subtractions, this cancel out, right? Numerator, denominator cancel out when you have same factor. And you end up getting x plus 4 minus 4. Positive 4, negative 4 cancel out. This gives you x. So that's going to be your composition function of this two function, which is the linear, right? If it's a linear, there's no restrictions. So there you cannot find any restrictions, linear, right? Same thing on this inner function. Inner functions, you have a fraction form, but you don't have variable on denominator, which makes this one linear again. So there is no restriction to pick x. So you cannot get restrictions. It means your domain is going to be all real number, right? So domain is going to be all real number. Since you cannot find restriction from inner functions or function itself. Let's try the other one. G of x functions. Right? you're going to replace f of x, which is g of x is x plus 4 over 3. Your x is 3x minus 4. If it's a fraction, you want it to simplify numerator by numerator, denominator by denominator. So when you simplify numerator first, opposite cancels out. You get 3x over 3. 3 over 3, that's 1. So which will give you x. That's another linear, no restrictions. F of x functions is linear, no restrictions. So it means your domain is going to be all real number also. So these types of composition functions, we're going to use this, find the inverse functions. And inverse function is going to be the next topic.